All right, on to our next lesson, section 2.1.8, writing equations given different representations. So in this lesson, we're just practicing writing the equations and based off whatever representation we're given. So again, we have to think about what the pattern is, first of all, and then from there, once we know the pattern, what kind of equation it would be, and go from there. So for numbers A and B, again, you're in pretty good shape. You just have to find the pattern. Anytime we have tables, just a few hints here. Here we would be subtracting 12. And just remember, you always got to go back to term number 0. Okay? So if we're subtracting 12 going down, we'd have to add 12 to get the 0 value. All right? Same thing with this. Always make sure you get the 0 value. But as we look to C and D, we haven't done too many problems where we go from a graph to an equation. And I just suggest that if you see the graph, that we make it into a table. And again, I am using N and T of N because that's what the axes are labeled as. And remember, when we write our equations, we always need the 0 value. So I'm going to always start my table with 0. 1, 2, 3, 4, 5. And so I have 3 as 1, 4 is 4, and 5 is 16. So if I look at this, I am multiplying by 4 going down. So I'm going to have to divide by 4 until I get that 0 term. So 1 divided by 4 is 1/4. Divide by 4 again would be 1/16. Divided by 4 again would be 1/64. Again, leave it as a fraction, not a decimal. And so my equation would be y equals 1/64 times 4. And again, I should be using T of N and N because that's what the axes are labeled as. T of N equals 1/64 times 4 to the N power. So again, if you see a graph, make it into a table. The other thing, we haven't really seen these tiles, but again, make it into a table. Because we've been working with writing equations from tables the whole time. So if we just write anything different we see as a table, it becomes a problem we've been doing for a while. Just remember, always start with your 0. And I count the number of tiles because that's what it says T of N is. So this would be 6, 7. This would be 1, 2, 3, 4, 5. 5 times 2 is 12. And then I have 1, 2, 3, 4, 5, 6, 7, 14 plus 3, 17. If I look here, that means I am adding 5 as I go down. And I would have to subtract 5 to get my 0 term. 7 minus 5 is 2. Now remember, this is going to be now arithmetic because I'm adding or subtracting. So this is going to be y equals mx plus b form. My slope is 5, and my y-intercept then is plus 2. So key things, takeaways, make everything into a table. Always make sure you're going back to the 0 term. And just be aware of whether it's geometric or arithmetic. Remember, if you're multiplying, it's going to be arithmetic, if you're multiplying, it's geometric, which means it's in that exponential, y equals initial value times your multiplier to the x equation. If it is adding or subtracting, it's arithmetic, which is y equals mx plus b form.